Okay, welcome everyone to the XGBoost is Overfitting webinar. This is actually take two, so some of you might have joined me in my first version of this, and sadly we had a crash in the middle of that. So this is my attempt to rectify the crash here. So I'm excited that folks are joining us. We got folks from all around joining us today. I'm doing this on YouTube this time. Last time I did it on Zoom, and Zoom has a limit. So if hopefully YouTube will let us go over that limit if we want to or if we need to. So how this is going to work, I've got some content that I want to talk about looking at XGBoost and understanding how it overfits, and then some techniques for addressing that overfitting here. We got people chatting in from the chat from all over the world. So thanks for joining us. Thanks for those who were here last time, and I'm curious if you're joining us today, I'd love for you to put in your chat your experience with XGBoost and what you hope to do or are looking to do with XGBoost. It's useful to see how people are using it and what they're looking to use it for. I think a lot of you know me based on either my content with Metasnake or my LinkedIn or Twitter, but for those, yeah, some people have attended some of my talks. So for those who don't know me, my name is Matt Harrison. I run a company called Metasnake. Metasnake does corporate training in Python and data science. And recently, I've been doing a lot of training around XGBoost. So I wrote Effective XGBoost, which is my take on XGBoost. And that book kind of opened the doors. A lot of folks have seemed to express interest in kind of learning how to take XGBoost to the next level. And so recently, I've been doing a lot of training with XGBoost with clients about how to incorporate XGBoost with their data sets and how to make them work for them. So what I thought it might be good to do is discuss some of my findings and some of the things that I've been doing with some of these clients. Because I think, first of all, it's certainly useful, but second of all, here's my cynical take. My cynical take is that there's a lot of content on social media that's like, learn SQL and you're good, or quit your job and you're good, which is fine for fuzzy feelings. But a lot of people need to actually provide value. And it turns out that there's a lot of value stuck in Excel spreadsheets and stuck in SQL databases. Actually, a lot of, I would say, the crown jewels of companies are sitting in Excel spreadsheets or in SQL databases in tabular formats specifically. And so because they are sitting in tabular format, XGBoost tends to be a great way to extract value out of them. In fact, it's probably one of the best ways to do that. So XGBoost, I assume most of you are familiar with it, but in short, if you're not, XGBoost is a machine learning library for making predictive models. And it excels for tabular data, and it's been used for a long time with Kaggle, winning a bunch of Kaggle contests. You've probably seen a bunch of social media posts around how good XGBoost is. But a lot of people are using it because it tends to perform quite well out of the box, and it has a bunch of features that other machine learning libraries or more traditional machine learning libraries don't have. So that's why I'm finding a lot of my clients are using it, and they're getting a lot of value from that. Okay, so I'm just reading through the chats here about how people are using it. Some people are new to XGBoost. Some people have seen some of my talks before. Okay. Yeah, and some people are saying that they are seeing some overfitting. Okay, so we're going to proceed with the content here. In general, some of you who have been in my content before know that I'm relatively flexible. So I'll keep an eye on that chat. If you've got questions, feel free to throw them in there. I'm happy to. Um, I mean, I have a path through here, but you know, we can. Deviate slightly off script if we got questions that are asking those things. Okay. So I'm going to be talking about how XGBoost is overfitting, which maybe it is a little bit snarky here. Um, yeah, if you want to participate in the chat, you know, a lot of you told me where you're joining from. What your experience with XGBoost is probably useful to me, what industry you're in, and what you're planning on doing with XGBoost. So I'm going to demonstrate a task with XGBoost, and my task is predicting whether someone will buy my Effective Polars book. So I actually just updated Effective Polars. Polars 1.0 came out. Actually, Polars 1.1 came out 2 days ago, I think. But I just updated my Polars book to support Polars 1.0. And so, you know, I've got a mailing list with a couple thousand people on it. It might be useful for me to kind of understand who's buying my book and what's causing them to buy my book. So I'm going to walk through doing that. So I think this is the interesting thing about this is like, this is not the Titanic data set. This is not something you've seen before. This is like my real world data. So I'm going to load my data here. We'll use polars to do this. And I'm not really going to walk through what's going on here with the polars code, so to speak. But I'll you know, if you're interested in that sort of thing, you know, I have content around that. But for me, the interesting part here is that I've got this data frame, and it's got like when this person started like having interactions with my company, how much they bought from me, whether they used a coupon or not, how many books or bundles they bought, whether they bought things off of Twitter, whether they bought my pandas content, and this last one is whether they bought a Polars book. So the idea here is to try and understand people who are buying that Polars book and what's different about them versus other folks, and maybe I can do some sort of marketing or targeting to reach those folks. So that's my goal here. Okay, so one of the cool things about XGBoost, for those who aren't familiar with it, and maybe let me just describe the XGBoost algorithm quickly for those who aren't familiar with it. So traditionally, you know, when people need to make classification models where they're predicting a label, someone will do this, or someone has cancer or something like that. The traditional model to use is logistic regression. And the nice thing about logistic regression is it's simple, it's fast, it's explainable. It is a linear model, and I'll talk a little bit more about that. But basically, it means that like if you've got some feature that you're trying to make predictions on, as it goes up or down, a linear model can only go, you know, it can go up or down as the other value goes up or down, but it can't do some sort of U-shaped curve or some S-shaped curve or some, you know, non-line shape out of the box. And so XGBoost is a tree-based model. It's based on decision trees. And the cool thing about decision trees is that they support nonlinearity. So if you think about how a decision tree works, it basically scans through all of the columns in a data set and looks for a point in a column to split the data and to do the cleanest split of the data. But then as it splits the data, it's going to have these nodes, and it can repeat that process of scanning through all of the columns, and it can actually hit the same column again. So if you had some sort of U-shaped curve, XGBoost would be able to model that U-shaped curve, or a tree-based model. It doesn't even have to be XGBoost, it would just be a decision tree. And so that's the cool thing about decision trees. And a couple other things that are cool about XGBoost is it does support missing values. So for example, logistic regression doesn't out of the box, and it also supports categorical values as well. So if you have non-numeric values, you can use those in XGBoost, which makes it really pleasant to use. also like logistic regression or linear regression, those linear models don't support missing values. They also don't support categorical values out of the box. So you have to do some pre-processing to support those. So the thing that makes XGBoost, I think, super powerful is this analogy where if you, I like to compare it to golfing, and I'm not a great golfer, but I'll go golfing every 5 years or something. And a lot of machine learning tasks you can think about like golfing, right? In golf, you have this little teeny ball and you're trying to hit it into this hole. Okay. And so a decision tree, I like to compare a decision tree to being able to take one swing at this ball and you hit it and it's some distance off from the hole. And you know, wherever you hit it, that's your prediction, right? So you can think, you know, for a regression where you're predicting a number, it's just, you know, this is the number we predicted, how far down we hit it. Or, you know, if you're thinking about a classification model where we're trying to predict a label, you can think of that as some probability. And the closer you get to that, the closer your probability is to being correct. So that's a decision tree. And decision trees, you know, I think are really powerful because they support nonlinearities. Decision trees also will overfit out of the box if you let them, because they can just grow as deep as you want and they can get very complicated. And that is one of the things that we need to be aware of. So oftentimes people will prune back these decision trees to make them less complicated and less overfit and get better performance. And then you have other models like random forest. And random forest we can also compare to golfing, where random forest would be like taking 5 of your best friends or 50 or 500 of them. And, you know, most people golf slightly differently. They have different clubs. Someone might be left-handed or right-handed. They have different experiences. So they're going to hit the ball differently. You know, even two people using the exact same clubs and, you know, with the exact same training will probably hit the ball differently. And so you can think of a random forest as, instead of one person hitting the ball, and this is your prediction, you've got 5 people hitting the ball. Some people might overshoot, some people might be low, but we're going to average the results of those. And tends to be that random forests perform better than decision trees for a lot of classification and regression tasks. And then if we have XGBoost, these boosted models, if we put them into this analogy, a boosted model is saying, I get to hit the ball and I have some error. Oftentimes, statisticians will call that the residual, but how far I am off from the hole. And with a boosted model, what we're going to say is you get to, from where you are, you get to now make a new model that fixes that error. And it's just like golfing, you get to hit the ball again, and you can make a model that can hit the ball 100 times, 500 times, 2,000 times. And so if you think about it from that point of view, where a decision tree is hitting the ball once, random forest is you and your friends hitting the ball and averaging the results, and something like a boosted tree like XGBoost is you get to hit the ball X number of times. Generally, I'm going to take where I get to hit the ball X number of times. And that is in part of the reason why XGBoost is really powerful. Now, there are a bunch of other things, and I'm not really going to get over that, go into those in this, but I do want to say that making a model with XGBoost is not particularly hard. In fact, let's look at the code to do that. So here's the code to do that. I'm gonna import scikit-learn here, and scikit-learn, if you're not familiar with it, is probably the de facto library in Python land for dealing with tabular modeling. And it has all of your models. It has logistic regression, decision trees, and it even has boosted models, but we're going to use XGBoost instead of scikit-learn's boosted models. But what I'm going to use from this is this train test split. So I'm going to hold out some chunk of my data, and I'm going to train my model on the rest of my data with the intent there to be that I want to simulate how my model will be doing in the real world. Okay, and then making a model with XGBoost or anything in scikit-learn is not hard. It's like 3 lines of code to do that. So the first line of code is this right here. We're going to import the library. In this case, we're importing XGBoost. And the second line of code to make our model is to make an instance of the model. So here it is. And then the third line to make the model is to call fit. Okay, so I'm doing some other stuff up here. I'm like prepping this X variable and this Y variable. You can think of X as the table of data, and then Y is the labels that you're trying to predict. And then I'm using scikit-learn to split those up. So I'm going to fit it on the training data, and then I'm going to call score here on this. And you can see that with the training data, I get a score of 0.957. By default, this score is the accuracy. So we're getting of all of our predictions, whether someone will buy or not buy XGBoost. With our training data, we get a score of like almost 96%, which seems pretty good. And then we have our score of our testing data. Again, this is the holdout data. This is the data that our model hasn't seen. And with that, we're getting a score of like almost 92%. So there is a discrepancy here, right? We have a high accuracy with what we trained it with and a slightly lower accuracy with data that it hasn't seen. And so, is that a problem? And with many things in the land of data science, it depends. It might be, it might not be. Oftentimes, when I am modeling and like teaching this to my clients, we will compare it to other models, right? And it's good to have a baseline, and like a linear model is a good baseline, like logistic regression. So the cool thing about, because scikit-learn and XGBoost both follow the same API, like making the scikit-learn model here is like 3 lines of code as well. We import the library, we make an instance of the model, and then we call fit. Now, again, there might be some additional data prep that you might have to do with logistic regression. In this case, my data is such that it kind of works out of the box with logistic regression. But the interesting thing here with this data, at least, is that my accuracy on the training data here is like 92.6, but also my accuracy on my testing data tends to perform similarly. Okay, so what is that telling me, right? It's giving me some insight. Well, first of all, it's looked like logistic regression is performing slightly better than my boosted model, and I just went on to say how great these boosted models are. So this tells me that it's possible that what is in my data is linear. There's not a bunch of non-linearities in there. But if we think a little bit further here. It was able to get 95% here. It is possible that this model is overfitting. It's too complicated. It's memorizing the training data such that it's not able to generalize to the data that it hasn't seen. And it's possible that if we actually lower that accuracy or make it so it doesn't overfit, we can raise up the accuracy of the testing data. Another thing to note just about this is that, like logistic regression, it's kind of hard to make logistic regression overfit. Logistic regression is a pretty simple model, and there are hyperparameters to hyperparameters are these abilities to tweak and tune a model. The hyperparameters for like logistic regression basically allow us to make it simpler. There aren't really hyperparameters that like make it more complicated. It's kind of hard to overfit a logistic regression. Okay, so what we're going to keep on going here. So that's my first sort of piece of evidence that like it might be overfitting. And I'm just going to cut to the chase here and say that my experience with my clients and with my own modeling is that when you use XGBoost out of the box, the default parameters tend to cause it to overfit. So is overfitting bad? Probably, right? And the interesting thing about XGBoost is that oftentimes, even with overfitting, an XGBoost model will perform better than like a logistic regression model or other models, even with overfitting. So that's kind of cool. But the nice thing is that if you address that overfitting, you can often get better performance and even boost that performance more. Okay, so let's just look at a little bit more evidence of overfitting here. A common thing to look at is what's called the receiver operating characteristic. So this is a plot that came out like during World War II. It was used for like radars to determine where tanks were on the battlefield. And in short, it looks at the positive rate against the false positive rate. And if you're not familiar with this, it's basically sweeping through a threshold of this classifier and saying what was our true positive rate versus our false positive rate as we sweep through this threshold of like what we classify as positive. And in short, what you want to do is you want a model that's going to say we have a really high true positive rate. And as we classify everything, it's going to start from this lower corner basically and go to this upper corner. And generally it tends to like bulge out up and to the left. Now, what I'm plotting here is I'm plotting the ROC curve for my training data in orange and my testing data in blue, and we see a gap between those. So oftentimes people will ask me, this is my ROC plot, and one way to quantify this is to like do the area under this. And because this is a unit square, you can calculate the area under this, and generally it's a score between 0.5 and 1. And you can see that the area under the testing data is going to be smaller than the area under this orange data. There is a gap between those. So it's just further evidence that there is some overfitting. So my thought when I see this is, and this is somewhat counterintuitive, I actually want to pull back this orange part if I can, not to make the model worse, but if I can maybe make this overfit a little bit less, potentially that can pull out this blue and that can improve my performance on data in the wild that I haven't seen. And just for fun, we can also do what's called a precision recall curve. And precision in short is like when you classify something as positive, is it really positive? And then recall is of all the positive things, have I pulled out all the positive things, right? And then those are kind of at odds with each other. In some cases, you want to make sure that something is positive before you say it's positive. In other cases, you want to capture all of the positive things. And so to do both of those at once is kind of hard. So there's often a trade-off against those. And that's what this plot is measuring, the trade-off against precision and recall. And again, I'm just plotting the training and the testing score. And you can see that there is a gap here. This one tends to bulge up and to the right rather than up and to the left. And it's also not strictly monotonically decreasing, but it tends to be somewhat monotonically decreasing. It can jump up just based on what's going on behind the scenes here a little bit. But we see that there is a gap here between this. There's just further evidence that there's probably some overfitting going on. And again, what I'm trying to do is boost up this blue line, and by boosting up that blue line, the orange line is probably going to come down. I'm not super concerned with the orange line coming down. What I'm more concerned with is can I get that blue line to go up, so to speak. Okay, so let's just look at another example of overfitting here, or another diagnostic tool that you can use to look at overfitting, and that's this learning curve. Okay, so this is a learning curve. I'm using the yellow brick library to plot this, and if you're not familiar with the learning curve, this is actually a useful tool to diagnose whether something's overfitting, but it's also a useful tool to answer the question, should you invest in getting more data? Like I said, oftentimes companies have their crown jewels sitting in an Excel spreadsheet, and that data might be really expensive or very valuable, and getting more of that might be a challenge or an investment to do that. And so this is one of the tools that we can use to diagnose, should we actually invest in getting more data, but we can also diagnose whether something is overfit by using this. And the basic gist of this is we've got a bunch of training samples. This is the rows in our X data frame. And what we're going to do is we're just going to take a subset of those, and we're going to train a model using k-fold cross-validation. And then we're going to keep track of the scores for that, and then we'll add a little bit more data, do it again, add a little bit more data, add a little bit more data, and keep adding more data and look at our scores as we add more data. So this is the result of that. Again, this is looking at the accuracy, and you can see that with my data here, when I just have like 400 samples or something, it looks like the training score is relatively high. But again, we're not super concerned with the training score. What we're concerned with is that testing score. And you can see the testing score is a little bit lower. As we add more data, it looks like our model training score is going down, but our performance of our testing score is going up a little bit. Now, a couple things to note here, because this is using k-fold cross-validation, it is training multiple models at those different levels, and you can see that there are error bars up here. The shaded area is basically the error bar. So another evidence of overfitting is that you have tight error bars, you have like consistent performance up here, but you have maybe wider errors with your training data. That's one piece of evidence that it's overfitting, that these different folds might not be consistently performing. Another piece of evidence is just the gap between these. Ideally, what we would like to see is that this green line is sort of coming up and this blue line is coming together. And if they're close together, that's indicating that we're getting similar performance with them. And then finally, that question of, should I invest in more data or not? How you can diagnose that is you can look at this green line. You can kind of look at the slope of this. It looks like it's kind of plateaued here. So I'm not quite sure that I would get much more boost by getting more data here, but there is a slight bump up in this last one, so possibly we could get a better performance if we got a little bit more data. Now, another thing to note about this is that this plot is specific to your data. It's also specific to your model, and it's specific to the hyperparameters of your model. So just because I have this overfit XGBoost model, it's kind of saying, I'm kind of interpreting this is that it looks like it's plateauing off. Does not mean that if I had tuned the hyperparameters, and so same model but different hyperparameters, I might get a model that could learn more if I had more data coming in with this. And there's a question about a link to a notebook. That will be in, I'll have the link to the notebook in the webinar page on Metasnake. Okay, and just one more piece of information that might be a hint of overfitting, and that's looking at feature importance. So a cool thing with tree-based models is that you can divine by looking at a tree-based model of the position in the tree of where a column is explored about how important that is. Because generally, how tree-based models work is it's going to go through all of the features, all of the columns, and it's going to say which one of these should we split on. And you can think about that. Okay, well, if it chooses one to split on, that's because that's the most important one, or it's going to do the best job at that point in time. So nodes that tend to be higher in the trees probably are more important because they are splitting up the data more. And so there are various metrics that are used, but basically you can ask your model, you can say, what is the importance here of the node or the column? And this is saying that the used coupon column is pretty important. You can see, here's my columns, and it's saying that used coupon is pretty important. Now, why am I saying that this is evidence of overfitting? This is a little bit kind of reading the tea leaves, but what I'm seeing here is potential evidence that we might be paying too much to this used coupon column because it's it tends to be the one that's like very important, and the others are less important. So it is possible, and we kind of have evidence of overfitting in those other things as well. So I'm just putting this up there and saying it's possible that if we address that overfitting, our model might be overfitting on used coupon, and we could see this feature importance maybe shrink down a little bit for using coupon. So if you see feature importances where you have one or two features that are very important and the others are less so, might be an indication to you that your model is overfitting. Okay, so let's talk about tuning here. And so tuning is that process of taking those hyperparameters, these are parameters that control how a model behaves, and using them to influence the model. Okay. Now, again, like I said, logistic regression has a few hyperparameters. You can adjust those. They will tend to make the model simpler. You can't really push it to make it overfit, so to speak. Really easy to make a decision tree overfit. All you have to say is like, make this tree go as deep as it can, and it can basically memorize what's in your data. And there might be reasons why memorization of the data might be important, right? I mean, you can use that as a surrogate model to explain what's going on, and the tree can basically explain what's going on because it's memorized the data. But oftentimes we're not using a tree just strictly for the explanation. We're oftentimes using it to make predictions, and the overfit model is not going to do a good job making predictions as a model that is better tuned. Now, one of the challenges with a tree or a model like XGBoost is there are a bunch of hyperparameters, and they do a bunch of different things. And oftentimes, if you're looking in like social media or whatnot, you're like, here's how you tune your model. You throw it into this grid search thing or this random thing, and you let it go. And that might do an okay job. The issue, there are a couple issues there. One is that a grid search is kind of brute force. It's just going to look at all these combinations of things, and some of the combinations might make sense, but other ones might not make sense. Random searching, the idea there is that rather than doing brute force of everything, it's just going to randomly choose combinations and hopefully get some combinations that work okay. That's slightly better, but I like to use tuners that are a little bit smarter. So I like to use a tuner called HyperOpt. And what HyperOpt does is use Bayesian modeling. And instead of you specifying the different values to search for, some of these values are like the depth is like 1, 2, 3, right? Those are whole values. But other ones are floats, right? And it could be 0.001, or it could be range up to like 10,000, right? So for you to make a grid search where you specify all these different values would be either annoying or just take a long time to like specify the values, where the Bayesian modeling, what it does is you specify a distribution, and it's going to be smart about it's going to sample some point from the distribution, and it's going to look at the performance there. And if the performance is getting better at a certain point, it's going to exploit that fact and keep sampling close by. Every now and again, it will do like an exploration where it will make sure it's not in a local maximum. And that tends to do a better job in my experience. I take this a step further. You still have, I mean, XGBoost probably has 20 plus hyperparameters that you could tune. So if you have that combinatorial explosion, like testing this, then testing this, that can take a long time. And if you have a cluster, you can set it off to work on your weekend. But oftentimes, when I'm working with my clients, they would like something a little bit quicker. And so what I've taken to do is I use what's called stepwise tuning. And the idea there is that instead of tuning all 20 hyperparameters at once, we're going to tune a small subset of hyperparameters. And I've basically broken these hyperparameters up into different groups here. So this is the code that I use to do that. And then down here, you can see that I'm going to say, okay, for this round, I'm just basically going to deal with the tree, the depth, the min child weight. And then for this round, I'm going to deal with sampling. So which rows, which columns we use to make these trees. For this round, I'm going to deal with my alpha and my lambda. For this round, I'm going to deal with my gamma. And for this one, I'm going to deal with my learning rate. What that does is it just focuses on a small subset and then takes those hyperparameters, the best hyperparameters from that subset, and uses those for the next round when it does tuning. Now, is this guaranteed to not be in a local minimum? No, it's not. But my experience is that using this tends to be a lot faster, and I can get a pretty good tuned model relatively quickly here. So I'm not going to run that because it does take a little bit of time to run. But these are some parameters that I got from running that. So I'll just put these into my model. And when I do this, you can see that my model score has jumped up a little bit. It's like 0.91, and now it's 0.92. Another thing that you might want to be aware of is like, what is the best iteration? How many trees, how many times you're swinging at the ball here? And this says 23. And so I might come back in and say, okay, this is the number of trees that I need there. And okay, so it looks like we're getting somewhere around 0.9293 with that. And if we look at our original model was 0.91. Now I'm going to make a comment here. A lot of people think that, this is like a waterfall process where like I'm just going to go through XGBoost and I have this process and then I'm done at the end. And so I kind of optimize for speed at the start. I kind of want to validate my ideas, make sure that a model's sort of working, and just validate that things will work. And so I might just do a holdout, right, and do my stepwise tuning to get a model that I think works pretty good out of the box. Now it is possible, certainly possible, that based on the split of your data, right, that you might either get a bad split or a good split, or a split that's more favorable to logistic regression, or a split that's more favorable to random forest or XGBoost, right, just based on the randomness of like what samples are in this training and testing data. And so be wary of these scores. They're good for like a gut feeling, but like just because one score bumps up a little bit or is a lot better than another one, it could be the case that that's just kind of luck based on what's going on there. So oftentimes I won't end my exploration modeling there. I'll do a further k-fold validation to kind of make sure that the performance is really where I want to and it's consistent across the folds there. So now that we've got this model that's slightly tuned, let's look at it. So we're going to look at the ROC curve here and look at that. We got the training score and the testing score, and now these are overlapping basically. So that's pretty good. It's telling me that we're getting similar performance from our training and our testing data, and that by tuning the tree to not let it overfit, we're doing a little bit better. Let's look at our learning curve here. And our learning curve looks a little bit different as well. Now, one thing to be aware of with the learning curve is when you're comparing these things, you do want to be aware of like the y-axis here. So this y-axis is going from like 0.9 to 0.94. Our learning curve up here was going from like 0.9 to 0.98. So make sure it's an apples to apples comparison when you're doing that. But what I'm liking here is I'm liking that like these tend to be converging. It is a little bit weird that as I add more data here, like our training score is going up here. And I see this going up as well. So I'm potentially thinking that, yeah, with this model based on these hyperparameters, it is possible that we could get a better model if we invested in more data. Another thing that I'm liking here, I mean, we do have a slightly wider error band here with our testing scores, but I am liking that like we don't have super tight bands here with our training scores. Again, telling me that we're probably not overfitting as much on that. Just giving me that evidence, and then we can look at. Here is what our feature importance was before. Remember, we have that large used coupon here. And if we look at this after our tuning, we can see that used coupon is not even the top feature anymore. Again, just further evidence that our tuning has probably helped address some of that overfitting. Now, it looks like there's some comments or questions in the chat. I'm going to go through those here if I can. And again, if you have questions or comments, please put them in there. JR says, can boosted models be thought of a form of SGD? Yes, they can be. JR says, I've heard that overfitting actually means that your model has the ability to learn. Yeah, I haven't really thought about it that way, but possibly, yeah. Yeah, so AXS Pinnacles is just asking about like the distributions in the tuning code. So you have some distributions where you're kind of like flat. You know, I want to go from like 0 to 10. You have other ones where you go from like very small values to very big values, right? So depending on what those distributions look like, you might use a different distribution for hyperop there. Maro says, did you tune your model only with your training data to reduce overfitting? Yeah, the tuning was with the training data to reduce overfitting there. Okay, that is one of the cool things that I like is using that stepwise tuning. I'm not seeing a lot of people doing it, and I'm not saying that you won't necessarily get into a local minimum here, but generally you at least deal with that overfitting by doing that, and then you can take those steps and throw that into a cluster and let it run over the weekend. If you want to sort of tweak and max out those settings. But I found that a lot of times just doing this, and it can run pretty quickly depending on what your data looks like, you can get relatively good performance very quickly by doing that. Kevin says, how do we interpret the feature importance changing now that bot pandas is the top feature? Is that the true top feature? So again, true top feature, it depends. It depends on your model, depends on your hyperparameters, right? But what this is saying is saying for this tuned model and for this metric that XGBoost is using for feature importance, it says that bot pandas is the most important. So I guess the question might be like, these swapped around a little bit. Is that disconcerting? Yeah, they might swap around, right? And to me, just on my gut feeling, someone who's maybe a subject matter expert in this data, the notion that bot pandas and book count are now more important kind of makes sense. If they buy books and they bought pandas, they're probably interested in polars too, and they're probably interested in a book, right? So I kind of, just from like looking at this, kind of makes me, okay, that kind of makes sense, right? JR says, in terms of feature importance, is this like univariate feature importance? How about interaction effects? Yeah, so we'll talk about interactions a little bit to JR. Okay. So one thing that is kind of cool is we like a lot of people will kind of tune their model and they're done, right? And I actually don't think that modeling should end there. And oftentimes, my clients don't even want to use XGBoost in the end. They want to use logistic regression for various reasons. So can we use like XGBoost to help us make better logistic regression models? And my experience is yes, we can. And one of the cool things that we can do is we can use tools like SHAP to look at how our model's performing, and then we can derive insights about the model and the data and use that to improve an XGBoost model. Now, one of the things you might want to look at is just the correlation coefficient between your columns in your data set here. So I'm just using some pandas code to throw this up very quickly. And I'm doing the Spearman correlation coefficient. So that's a monotonic or a rank correlation versus the Pearson, which is the linear. So, you can have some sort of S or curve shape, and that can still have a high Spearman correlation coefficient. And so what I'm looking for here when I do this is just very dark blue values or very red values. Now, along the diagonal, you see the dark blue values because that's a correlation of something when it's with itself. When that value goes up, it goes up is basically what that's saying. So kind of try and ignore that diagonal there, but look at the other the other cells in there. And for example, I can see that like total cells has a pretty high correlation with bundle count, 0.57. Looks like that's probably the largest correlation here. And then it looks like there's a slight negative correlation with start year and course count. So as start year goes up, course count tends to go down. And because I know what this data means, that kind of makes sense because my courses have kind of gone down over time relative to my other work. But we can use this to sort of say, okay, is there some relationship? We might want to look at like this bot polars, which is what we're trying to predict. What are like highly correlated things with bot polars, right? And it looks like total cells, use coupon, have slight correlation there, book count, and bot pandas. There's a slight correlation there. So that might give us some insights. Oftentimes, I'll do some scatter plots just to look at that a little bit more. But oftentimes, I'll use SHAP instead. So SHAP is a third-party tool that works with a lot of models, and it uses game theory to basically say how important things are. So this gives us like feature importance, but it's using a different way to calculate that than say XGBoost is. And so what I might want to do is I can do this B swarm plot here, and let me get rid of my face so you can see this. So at the bottom here, we have the SHAP value. And this isn't a plot that I would necessarily give to my boss unless they're technically savvy. But what the SHAP value is saying is a value that is above zero, a positive value, is going to push us towards the positive case. In this case, the positive case is they bought the Polar's book. A negative value is going to push us towards non-buying. Okay, and then what this is rank ordered here. So according to SHAP with my model, it's not saying that bot pandas is the most important. It's actually saying that start year is the most important. Okay, so again, like that question of like, is something truly the most important? Well, uh, you know, there's the notion of like how to tell lies with data, and depending on what metric you're using, you can make cases for different features being more important or not. So I'm not necessarily super concerned. If they are in correspondence, that's great. If they're not, it is what it is. It is using a different metric here, but I can use SHAP in other ways as well, not just to validate that the ordering is the same. So we also have this coloring here on the side. So a blue value means a low value for start year, and a red value means a high value here. So interesting here, what I like to see is sort of a smooth gradation from like a blue to a purple to a red. It looks like I'm not quite seeing that here. I'm seeing like a light blue and a dark blue. I think those should be switched if we were to see that. If I see that smooth gradation there, what that's telling me is that there's probably a monotonic relationship between that feature. And then we can see some other things as well here. Someone talked about interactions. And so here you can see that there are a bunch of just high values here, but they're spread out. So given the same high value for start year, some of them might really push us towards buying the book, and some of us might push us towards buying the book, but not as much. So when we see that horizontal spread there, that's an indication that we have an interaction. An interaction meaning some other column is interacting with start year to determine whether or not we should buy the book. So this is a cool tool just to like validate that. So I can also do these scatter plots here with this. So let's take start year and do the scatter plot. It looks like this. Again, not necessarily a plot that I would just give to my boss without any context about what's going on. But in this case, we have the start year along the bottom x-axis here. And then we have the SHAP value here on the left-hand side. So it's kind of taking what we had up here and rotating it, but also spreading it out across the values here. And what we're seeing here, again, SHAP value, a value above zero, pushing us towards buying the book, a value below zero, pushing us towards not buying the book. We're seeing that basically people who joined in 2023 or 2024 are more likely to buy the book than those who didn't. or at least based on start year. Now, again, we do see some spread here, right? From 2024, we see some spread here. And the vertical spread in this case is indicating that there's some interaction with other features there. Let's look at total sales. Total sales looks something like this. So as total sales go up, you can see that like it looks like, you know, if my total sales go above some threshold here, somewhere around maybe 100 or something, then we're saying, okay, generally people who spent more than 100, we're going to say they're going to start being more likely to buy the Polar's book versus those who haven't. And we can look at like book count as well, and we can see book count as people buy more books. You know, after they've bought 2 books, they're more likely to buy the Polar's book. So this is kind of interesting. And what I can do with this is that there's another hyperparameter that XGBoost has, which is the ability to specify what we call a monotonic constraint. So oftentimes, even though you have a model that's tuned, there still might be data or noise in the data that is impacting your model, and you can have a model that is even simpler, or you might have some intuition about like the mathematical properties of the data. And I can come in here and I can say, okay, well, it looks like if they buy more book counts, that should push us towards a more positive case. If the total sales go up, that should give us a positive case. But it looks like this is not necessarily monotonic, right? It's up and then it goes down for whatever reason. People in 2022 don't like polars or whatever. But this could be like the content that I released in 2022 was content that isn't polars kind of specific or polars tangential, and so folks aren't interested in that, so to speak. So I think there's interesting things that you can sort of try and read these tea leaves by going off of, but I can come in here and now I can specify, let's put in some monotonic constraints, and let's make a model with monotonic constraints. And we can see that this simplifies the model, but even though our model is simplified, we're keeping that score that's relatively similar there. And if we look at our ROC curve, it looks like we still don't have that evidence of overfitting. Now, this is probably going to affect our feature importances a little bit, and we can see that this pushes book count up to the most important now, right? And so again, the feature importance is a little bit reading the tea leaves. But oftentimes I have clients who are dealing with like weather or crop or health things, and they know that there is a relationship there. When something goes up, the predicted value needs to go up or down, and they want to force the model to do that. And so a monotonic constraint is a really cool way to say, stop sort of looking into the noise and just follow the pattern that's there. Diego says, can you use SHAP with multi-class problems? Yeah, SHAP works with multi-class problems as well. So one more thing that we might want to look at is these feature interactions here. And again, the notion of a feature interaction is that we saw in SHAP that there's these spreads, right? When something has the same value, but it might have a SHAP value from low to high, that's indicating that there's some other feature that's helping boost it, depending what the other feature is. You can think of this in a tree shape as like, here's a tree value up here, and then immediately in this node, it's followed by another node. And if you see this node followed by another node in a bunch of trees, that's probably an indication that there's some relationship between those two as they interact. And so it turns out there's tooling that can help us determine that here. So I'm going to use this library called XGBFIR. The interface here is a little bit weird. You like tell it to run, and then it makes this Excel spreadsheet. So I'm basically just going to dump this spreadsheet and then read it in here. It's got a bunch of sheet names. So the first sheet name is just going to give the features, and it's going to give a bunch of metrics around those features. And again, you can see that these features are a little bit different than our features up above. So again, these are using different metrics, and so based on your metric, you can kind of make your features do whatever you want. But the cool thing with this is not necessarily that first sheet, but it's probably the second and third sheet. So if we look at the second sheet, which is interaction depth 1, you can see that now we have bot pandas and start year. So this is saying that this is the biggest interaction. It is seeing bot pandas followed by start year the most times in our trees that we're making. And then start year used by use column, and then book count used by use column. So as a subject matter expert, you might want to go through these and say like, oh, I like that. I want, age and weight to interact, or I don't want, state and age to interact. And you can tell XGBoost to simplify, in essence, your model even more by using interaction constraints. Okay, so we're at the end of our webinar here. So in summary, XGBoost is tending to overfit by default, and you need to be aware of that, because even though, and it's certainly possible that even with overfitting, XGBoost is doing a better job than a lot of models, even when it's overfitting. But when you stop overfitting, you get a better score. So how can we do this? First of all, you need to be able to diagnose this, right? And I give you various tools to diagnose this. You can look at those metrics, right? You can look at the ROC curve, you can look at the learning curve, and we can even look at the feature importance there. That can give us some notion of what's going on. How do we address this, right? And so, a lot of people think that tuning is the one way to address this. Certainly that is one of the tools that we have in our toolkit, but we can also add data, we can add features to our columns, and then we talked about this notion of constraints. And then one of the cool things about looking at the SHAP and like those relationships there, logistic regression doesn't have the ability to do those relationships or those constraints, but we can use our insight from our XGBoost model to actually create features and put them back in like a logistic regression or linear model and boost the performance of those. I got one more thing for you here. Like I said, I've been working with a lot of clients going over this. And so what I've decided to do is to make a course for this. And I'm going to be offering a cohort-based professional XGBoost course. This is a 6-week course. And what I'm going to do is I'm going to walk people through all of the pandas and Python code they need to do to start making these models, and to facilitate being able to quickly manipulate your data to get it ready. And then I'm going to show you how to use scikit-learn pipelines. This is going to enable you to quickly transform your data if you want to, and leverage these things outside of XGBoost, but also in XGBoost as well. If you need to do further transformation to make a logistic regression model, we're going to talk about that. We're going to dive deeper into model performance. I'll show you how to attach dollar values to your models and actually see if they make sense for your corporation. I'll walk you through my process of using SHAP, and we'll go deeper into tuning. And then I'll talk about what I do after. I've kind of made a preliminary model, what I would call. I often will do things after this that I haven't even talked about here. So there's gonna be 6 weeks to do this. I'm going to offer different versions of the course. One is just the content. Another course is a cohort-based course. There'll be homework. There'll be live sessions with that where you can interact with other people, but also ask questions with me, and I can talk about my process. And then there'll be a version of this where I'll have one-on-one interactions with you. If you have you want to apply this to your data at work, certainly you can do that. And that would be a place if you have questions that you want to ask that you want to be asked in private, certainly you can do that. So there's a question here. JR says, is this different from the book or course? Yeah, it is different because JR, after I wrote the book and did the course, I've had a lot of consulting where I've actually, I would say, more formalized my process, but actually gone through and addressed a lot of issues or questions people have that aren't in the book. Generally, the people who I'm doing the trainings with are people who have my book and course and want to apply this to their data. So for those who are in the webinar, if you are interested, if this is something that's interesting to you, I'd love to have you in here. So I'm gonna, there is a coupon and I'll put the code in here. Coupon is webinar. This coupon is good for today only. And this coupon will give you 35% off the course if you want that. So I'm pretty confident based on my work with XGBoost and my training with clients that people have a very hard time finding this. People are having a very hard time because a lot of this is folks' crown jewels. And, you know, it's really easy to talk about the basics of XGBoost and put up a Medium post on the basics of XGBoost. But when people work with their crown jewels, they don't want to put a blog post about that anywhere. And so these techniques that I'm using to sort of go above and beyond sort of the basics, you might be able to find them here or there scattered around the internet, but as sort of a process to walk you through, I don't know anyone who's doing that or at least offering that publicly. So I think this is a unique opportunity for professional folks who want to really make a difference in their company. Okay. So again, the code there is webinar. It's going to give you 35% off. This will be a 6-week course. Again, there will be a live component. There'll be homework, and for those who want an additional consult on top of that, that will be available there. Thank you for attending. If there are other questions, please put them in now. I'd like to address any other questions that folks might have. Okay. Well, I appreciate everyone's time. Hopefully you had some insights into some of the things that we can do with XGBoost. Yeah, there's a question, can I put the link to that? You know, let me put the link in there. And I'll send out an email with the link to this as well. There's a link to the course there. I will also put my notebook if you go to the page for the webinar, the notebook will be there, and I'll put this video there as well, so you'll have access to that. Yeah. Thank you everyone for your participation. Hope to see some of you in the course if that interests you, and have a great rest of your summer. We'll see ya. Bye everyone.